Welcome to this channel. Today I'm going to be showing you how you can write full redox reaction. Typically, you're going to be given a question along the lines of write the full redox reaction for the following pairs of half equations. I will show you how you can do that in this video. So let's get started. So the first question is this. We have to write the full redox reaction for this pair of half equation on the screen. So we have so the first thing you want to do is to confirm if we have equal number of charges on both sides, right? Then we go on to checking if we have the same number of atoms on both sides of the half equations. Okay, so here we have just one charge on this side, a -1, right? Here we have a 0, and then here we have a -1. The total on this product side is -1. So the charges are equal on both sides. What about the number of atoms? We have one atom of iodine here, and we have one atom of iodine here, because half of I2 means I. The second member of the pair, we have 4 hydrogen atoms here. We have 2 hydrogen atoms here and 2 hydrogen atoms here, making 4 hydrogen atoms. And what about this side here? We have 4 hydrogen atoms here. That is balanced. What about the number of oxygen atoms? We have 2 oxygen atoms here, and we have 2 oxygen atoms here, because these 2 multiplies through. Great. Now what about in terms of the charges? We have 0 charge here, we have +2 here, and we have -2 here. The total on this left hand side is 0, and the total on this right hand side is 0. So the charges are balanced. But because this equation is called redox equation, that means that if 2 electrons are lost from one side, 2 electrons must be gained from the other side. Now if you observe, we have 2 electrons here, but how many electrons do we have on this side here? We have just 1 electron. So what do? We have to multiply all through by a factor of 2. So we have to multiply the whole of this equation by 2. If we do that, then we can write 2i minus, then we have I2 plus 2e minus. So let us rewrite this one on the right hand side. H2O2 plus 2H plus. So we merge these 2 sides together. So we are going to have 2i minus plus H2O2 plus 2H plus 2e minus to give now the product side together, merge together. So we have I2 plus 2e minus plus 2H2O. Now, if you look very critically at it, you're going to see that we have 2 electrons on this left-hand side, and we have 2 electrons on this right-hand side. So we can cancel them out, right? Great. So cancel this out. What do we have now? We have 2i minus plus H2O2 plus 2H plus to give us I2 plus 2H2O. This is now the full redox equation. Next question, how do we do this? We have to write out the 2 half equations. So we have Cl minus once again, we need to check if the number of charges on both sides are equal. So for here we have -1, here we have a 0, then -1 from here. So the total charge here is -1, and this is -1. That is balanced. What about the number of atoms? We have 1 chloride atom here, we have 1 chlorine atom here, so that is balanced also. What about on this side here? The total charge here is 0. This one is +4. This is -2, and that's a +2 charge here. And this is +2, and this is 0. So the total charge here is +2. So in terms of charge, this is also balanced. What about in terms of atoms? We have Mn, single manganese atom here. Mn, 1, 1, yes. How many oxygen atoms? We have 2 oxygen atoms here, 2 oxygen atoms here. And we have 4 hydrogen atoms here and 4 hydrogen atoms here. That is balanced, very good. Now the next thing we want to do is to complete the number of electrons on both sides. Remember, it's a redox reaction. That means that if 2 electrons are lost from one side, 2 electrons are gained from the other side. So if you check here, we have 2 electrons gained here. That means that 2 electrons must be lost here. How do we do that again? Just the same way we did the first one. Multiply all through by 2. Right? Put it through here. 2Cl minus to give us Cl2 plus 2E minus. Right? Let us rewrite this right hand side here. We have MnO2 plus 4H plus. Great. So we need to now merge the two equations together. So the reactant side together first, then the product side together. So we have 2Cl minus plus then the product side together, we have Cl2. Great. So now if you observe on both sides, we have 2 electrons and 2 electrons. We need to cancel them out. So what is going to be left will be 2Cl minus plus MnO2 plus 4H plus to give us Cl2 plus Mn2 plus 2H2O. The next question, let us write the two half equations out. Check if they have the same number of atoms on both sides. So we have 1 atom of iron here and we have 1 atom of iron here. That is balanced. What about in terms of the charges? We have a +2 here and we have a +3 here, and this is a -1, so the total charge is +2. So we have equal number of charges on both sides. The same thing for this right hand side here. We have 1 atom of manganese here and 1 atom of manganese here, 8 atoms of hydrogen, 8 atoms of hydrogen. How many atoms of oxygen here? We have 4 of it, and then we have 4 times, oh, that is 4. That is balanced, very good. Now what about in terms of the charges? We have a -1 here because of this minus here, and we have +8 here, +8, and this is a -5. The total is going to be a +2. And what about this side? We have a +2 plus 0, that is a +2. So the number of charges on the right hand side are also equal. But if you observe, it's a redox reaction. That means that if 5 electrons are lost from one side, it must be gained at the other side. Apparently, 5 electrons are gained here, and we only have 1 electron lost from this side. That means that we have to make this electron here 5. But we cannot just put a 5 there. We have to multiply all through by 5. So to do that, we put in a bracket, I'll put a 5 here. So we're going to have 5. Then we need to write the other one. So the next thing is to merge the two sides together. Remember, the reactant together, then the products together. Now the products. So if you observe, you're going to see that we have 5 electrons on both sides, so they can be cancelled out. Eventually, you're going to have this full redox reaction. And this is how it is written. Okay, so I want to believe that you can write full redox reactions on your own. And perhaps you have any further question you want me to help you with, you can always drop it in the comment section down below and I will try my best to do justice to it. So can I ask that you like this video and also subscribe to my channel to keep me encouraged? Thank you.